you remember your name?
Miriam Albrecht.
What are your last memories, Miriam?
I was on a plane on my way to a conference in Reykjavik. And then everything gets blurry.
It's a miracle that you survived. All other passengers perished in the crash.
Hello, Mrs. Albrecht.
Professor Albrecht.
Professor Albrecht, my apologies. I'm here on behalf of Aerospace Systems. We just wanted to offer our sincerest condolences to
What happened?
As you know, we're a world leader in autopilot technology, in programming the safest and most reliable autopilots for planes. But on your flight, our code, it encountered an unexpected error. And when it hit this condition, it failed. Once again, we'd just like to...
You mean your software for your autopilot crashed in flight? Wasn't it tested properly?
Our autopilot software has been extensively tested in computer models and in test flights. It successfully passed all of the tests. However, as you know, you can't always test for every single condition. We'd just like to offer, again, our sincerest apologies for the condition that you went through.
Look, I don't... Tell your company I don't want their money or your flowers. I want the code.
How can I be sure this autopilot software will never fail? Engineers conducted hundreds of tests, but the bug still escaped them. How can I be sure that this stamp will always print the same pattern? I could use it over and check the result, but I can never be 100% sure the next impression will come out exactly the same. On the other hand, I could look directly at its foot and I can see that it has a single pattern carved in a rubber layer that cannot produce anything fundamentally different. Now, how can I make sure that the software is correct, that it will not fail under certain conditions? I need to look at the carved pattern of the autopilot code. I can deconstruct the logic of the code and reason through all the possible behaviors that it can produce. With this method, I can prove that the autopilot software will never ever fail. Of course, provided that the plane works correctly. I am going to write this proof, step by step. But as a human, of course, I can make logic errors myself, so I'm going to use a proof checker program to verify that the proof that I write is correct.
Have you tried to mathematically prove whether the programs were correct before putting them into your planes?
Well, we have our team of logicians reasoning through all the code, but as you know, there are hundreds of thousands of lines of code in the autopilot. It takes multiple years to verify that amount of code, and every time we change it, we have to rewrite the whole proof.
Automation. If I write a program that looks at the autopilot code and generates these tedious proof steps automatically, I will not need a team of logicians. This program could generate the proof much more quickly before the autopilot is loaded onto a plane and updated in time for every new version of autopilot.
Our work has reduced fatalities around the world through our reduction of errors in code.